Hello, this is Zoe Leitner, a student at the University of New England in the Medical Physiology course, and today I'm going to be giving a brief lecture and overview of the feedback loops in the non-gravid female reproductive system and the effects that these have on what is going on in female reproduction. Now we are going to go over a few slides that will go into detail about these feedback loops and the effects that they have. So I'll give you a little overview of what we'll be talking about today. So the feedback loops in the female reproductive system are very complex, and they are cyclical rather than steady state processes. So a lot of feedback loops in the body are involve steady state processes that attempt to bring the body back to homeostasis. And some examples of these that we have discussed in class include the respiratory system that attempts to maintain stable levels of oxygen and carbon monoxide in the blood, and other systems like this that always want to maintain certain parameters within certain levels. But with the female reproductive system, this is not the case, and we will see levels of hormones rise and fall at different points throughout the cycle. And so these interact in various feedback loops, and they are some of the most complex in the body, as we will delve into in just a second here. And so they're cyclical because they involve gamete production in monthly cycles that can be from 24 to 35 days, but on average are about 28 days, which is why it's a monthly cycle. And it can be called the menstrual cycle, which was originally named because of the observation of menstruation. And it is a very easy sign to observe early on in the cycle is menstruation because it is a clear occurrence. And it also includes the ovarian cycle, which describes changes in the follicles of the ovary, and the uterine cycle, which includes changes in the uterine lining. And it is very important to note that although these are occurring in different locations, they still have very complex and intertwined signaling processes that are contributing to both of them. And so this system is under the control of many hormones, including estrogen, progesterone, FSH, and LH, which are follicle-stimulating hormone and luteinizing hormone. And so we will discuss how these levels rise and fall throughout the cycle. So first I'm going to give an overview of the ovarian and uterine cycles. So because the ovarian cycle involves changes in the follicles of the ovary, it's divided into 3 phases. The first is the follicular phase that involves follicle growth. The second is ovulation, where the follicle bursts and releases an oocyte. And the third is the luteal phase, or the post-ovulatory phase, which is when a corpus luteum is created from the ruptured follicle. And so if no pregnancy is occurring, if this is a non-gravid female, then the cycle will repeat itself after the corpus luteum dies. And then the uterine cycle involves changes in the endometrial uterine lining. And so it begins with menses, which is menstrual bleeding or the shedding of that endometrial lining. It then goes on into the proliferative phase, where the endometrium adds a layer of cells, and this is in preparation for a possible child that the woman could be bearing. And so that is why we have layers of cells that are added. It is in preparation of the womb. And then it ends with the secretory phase, where the surface layers of the endometrium are shed, and this results in menstruation, and the cycle continues. So we have here a schematic that shows how different levels of various hormones fluctuate throughout the cycle, and it may appear as though they're acting independently, but it is very important to note that these involve very complex feedback pathways that can be both positive and negative and can change at different points during the female reproductive cycle. And so all of these hormones really do have a great influence on each other and what is happening during both the ovarian cycle and the uterine cycle. And then I'll also mention that we can see that there's a body temperature change. And so that's a very interesting occurrence that happens as well, which is something that I'll leave you to think about and bring up towards the end of this presentation. So don't forget about that because it is very interesting. So with the hormonal control, there is a great deal of hormonal control that influences how these different phases of the cycles are coordinated. So the follicular phase begins with FSH stimulation. And so that will stimulate tertiary follicle maturation, which is very important in production of the ovum. And so both LH and FSH are stimulated by GnRH production. And so then there are also, the FSH also influences granulosa cells, and those secrete AMH, which is anti-Mullerian hormone. And so it is believed that this hormone stops the development of too many follicles at once, because obviously it would not be beneficial for multiple follicles to be occurring at the same time, because the female body can only support one or very few developing fetuses at once. And so LH will then act on the thecal cells, and both the granulosa and thecal cells will produce steroids. And so thecal cells secrete androgens, and those are converted to estrogen, and this is done by an enzyme called aromatase, which converts the androgens to estrogen. And so the estrogen will then have a negative feedback effect on LH and FSH, which is important so that we do not have multiple follicles developing all of the time. So once the body is receiving those signals from the developing follicle through the production of estrogen, then it is able to shut itself off so that we only have that one follicle that the body is investing in. And so with the estrogen, then the endometrium also begins to grow in preparation for that egg that is coming. Then when the follicular phase ends, the granulosa also secrete inhibin and progesterone. And so it's very interesting because estrogen will then have a positive feedback on GnRH, gonadotrophic releasing hormone, when it previously had a negative feedback effect. And so this causes a surge in GnRH, and which also leads to a surge in LH. And so this is very important because with the LH surge, meiosis resumes. And so if we look at this part of the diagram that I've put here, we can see this LH surge and how it is directly correlated with the estrogen rising. And so we see the estrogen peaks right here, and then LH peaks a little bit later, but very closely after, because it is a direct influence with the positive feedback on GnRH. And so there's also a slight surge in FSH because it is also triggered by GnRH, but that is less so. And so then when meiosis resumes, we'll have the first meiotic division, where we will develop from a primary to a secondary oocyte, and then that will also result in the release of the first polar body. And so then, after meiosis resumes, we will have ovulation, where the follicle bursts, and this also occurs because of proteolytic enzymes and things that are released as a result of these changes in hormones that cause the follicle to burst when it secretes prostaglandins and proteolytic enzymes. And so then the follicle will continue to travel down the fallopian tube for fertilization. Then we have the luteal phase, where the thecal and granulosa cells become luteal cells and will form the corpus luteum. And so the corpus luteum is very important because it produces increasing amounts of progesterone, estrogen, and inhibin. And so progesterone is dominant during this part of the cycle. And it can be noted that estrogen increases as well, but it does not reach the same peak that it achieved early on in the follicular phase. And so these have negative feedback on the hypothalamus and anterior pituitary. And so with those, we have inhibition of um, the development of ovulation again, which is important because we already have a mature egg. And so with this, the endometrium continues preparing for pregnancy with thickening the lining. And then, as I mentioned with body temperature before, it is very interesting because progesterone also causes an increase in body temperature. And so this occurs after ovulation, so it can't indicate ovulation, but it can indicate the higher progesterone levels. And so then, if there is no fertilization of the egg, the corpus luteum will undergo apoptosis or programmed cell death. After approximately 12 days is the life of the corpus luteum without fertilization of the egg. And so with the death of the corpus luteum, progesterone and estrogen decrease, and because those have a negative feedback effect on LH and FSH, if progesterone and estrogen decrease, this in turn causes an increase in LH and FSH. And so then with those, we can begin the cycle again, and the endometrium will be shed and will leave the body through menstruation. So then we can look at this diagram, which shows both the relative levels of those hormones as they fluctuate throughout the cycle, and then we can also see various feedback loops that are occurring. So some interesting things to note would be that things like estrogen initially have a negative effect on GnRH, but then during the late follicular phase and ovulation, this switches to a positive feedback effect in combination with progesterone. And so that is very important in the progression of the female reproductive cycle. And these are very important things in understanding why it is cyclical and how these hormones interact with each other.